In this video, we're going to talk about what a slant asymptote is and how to identify a slant asymptote. So let's first take a look at the equation x squared minus x divided by x plus 1. Now in this particular situation, we see that we have a vertical asymptote right here. But because the degree of the numerator is greater than the degree of our denominator, we don't have a horizontal asymptote. Yet, as we look as x approaches infinity, we see that our equation gets really, really close and approaches y equals x minus 2. And because it's not horizontal or vertical, we call it a slant asymptote. So let's figure out how we can identify a slant asymptote and then how to find it. So a rational function will have a slant asymptote if the degree of the numerator is exactly 1 greater than the degree of the denominator. Here we have an x squared, and down here we had just an x to the 1 power, so 1 greater. Now to find an equation of a slant asymptote, you can divide the numerator of the function by the denominator. And the quotient will be linear, and the slant asymptote will be of the form y equals the quotient. And we can do this division using either long division or synthetic division. Now in this particular instance, with our x squared minus x divided by x plus 1, we can go ahead and divide using synthetic division because our divisor is in factored form, basically. If this was something that was bigger or not in factored form, we would probably need to use long division there. So because our degree was linear, a degree of 1, we can use synthetic division. So let's go ahead and let's set that up. So we're going to have a 1, negative 1, and a 0. And then we're going to go ahead and, because it says x plus 1, remember we're going to use a negative 1 there. And here we go. So we're going to go ahead and bring that down and multiply and put it up and add. That gives us a negative 2. We're going to multiply, put it up, and add. And here we have a remainder of 2. And here we can see this is going to give us an x minus 2 plus 2 over x plus 1. And so the part that is our slant asymptote is this right there, this x minus 2. So we'll abbreviate slant asymptote, and we'll call that our S dot A. So our S dot A in this particular instance is y equals x minus 2, as we can see from our graph here. And the reason why we leave off the, sorry about that, got things jumping around. The reason we leave off the remainder is because as x gets bigger and bigger and bigger, we actually see that this is going to start approaching closer and closer and closer to 0. And so essentially you'd have x plus 2 plus 0. Excuse me, not x plus 2, but x minus 2 plus 0. So we can kind of ignore that and just take the x minus 2 portion. Hence our asymptote is y equals x minus 2.